This lesson is on graphing parabolas. Parabolas are the shape when we graph a quadratic equation. So that means our x is going to have an exponent of 2 for all of these equations. When we first talk about quadratics, we talk about standard form. Y equals ax squared plus bx plus c. This is only one of the forms a quadratic equation can take. And when we look at it in this form, a, b, and c are very important to us, and we'll come back to those 3 points. Okay, what is different about these two equations? We have y equals 2x squared and y equals negative 2x squared. Well, the only difference there is the coefficient on the first one is positive and the coefficient on the second one is negative. So we have a positive 2 and a negative 2. What's different about their graphs? Well, for y equals 2x squared, we have this first picture, and for y equals negative 2x squared, we have the second picture. If the only thing that changed was we went from being positive to negative, what does that tell you? Well, it should show you that if it's positive, our parabola, if a is positive, our parabola is going to open up. If your a is negative, it's going to open down. Now, if you're wondering where I'm getting that a from, it's back from that top point at the beginning. A is the coefficient for x squared. So we see that if a is positive, the parabola opens up. If a is negative, then the parabola opens down. Sometimes we call them a positive parabola and a negative parabola, depending on which way they open. All right, another thing we talk about with parabolas is the maximum. The height of a diver, t seconds after jumping, is given by this equation. H equals negative 4.9 t squared plus 7.8 t plus 10. So h is our height and t is the time after he jumps. What is the maximum height he will reach? Well, we could plug in different values of t and make a table and see if we could find what that maximum height will be. But it's going to be quicker for us if we graph it. When we look at this graph, we can see the maximum point. We know we said that y is h, so this is our height. And our x is time, so this is time down here. So the maximum height is going to be this point right here. That's where our height reaches its highest point. And we want to know what that point is. We can use our calculator to calculate the maximum point, just like we calculated the point of intersection before, and we'll go over how to use your calculator in class. But that maximum point is where x is about 0.8 and y is about 13. So the maximum height he jumps is 13 feet. Another thing we talk about with parabolas is the minimum. For this one, we're going to talk about a pool. This pool is treated with a chemical to control the algae. This equation represents the amount of algae t days after the treatment. So we have y is our amount of algae and x is our time. We want to know, when will the pool have the least amount of algae? When it says the least amount, we know we're talking about a minimum. So we're going to graph this. And this is what our graph looks like. Well, if this is the algae over here on the y-axis, and this is time, and we want the least amount of algae, we're looking for where y is the smallest. Y is the smallest right there. And we can have the calculator tell us exactly what that spot is. And when we calculate it, it tells us that that minimum point, see, we calculated the minimum, was where x is 5 and y is negative 500. So the question asks, when will the pool have the least amount of algae? It's asking when. So we want to know the time. Time was x, so that would be 5 days after they put the chemical in is when the pool has the least amount of algae. A parabola has several important parts. One is the vertex, and that's the point we were just looking at, the maximum and the minimum. And another important part is the axis of symmetry. Well, we know about lines of symmetry. We learned about those in lower school. The axis of symmetry is the vertical line of symmetry for a parabola. Our parabola here is represented by this equation, y equals negative 3x squared plus 2x plus 1. We can graph that on our calculator, and we can tell that it has some symmetry to it. We can take this line and see the line of symmetry. Let's see, let me move that over. The line of symmetry looks like it hits right about there. And we can kind of estimate where that is, but we're not sure exactly. Sometimes it's very obvious and very exact, but not always. And so sometimes we need a little bit more. When we need an exact, we can use this formula. It's a vertical line, this line of symmetry, and we know vertical lines look like this, x equals something, and we need to know what that is. Well, remember I told you we'd come back to that a, b, and c, and here they are. For this equation, a is negative 3, b is 2, and c is 1. If we follow this formula for the axis of symmetry, we say x equals the opposite of b, so the opposite of 2 is negative 2 over 2 times a. And a was negative 3, so 2 times negative 3 is negative 6. If we simplify that, we get x equals positive 1/3. And that's where that line is. It's hitting at about positive 1/3. The next piece of the parabola we're going to talk about are the intercepts. The intercepts, we've talked about the y-intercept when we graph lines. The intercepts are where our graph crosses either the x or y axis. To find the x-intercepts, we graph the parabola and then estimate where it hits the x-axis. The x-intercepts are where y equals 0. We know that y equals 0 on the y-axis, on the x-axis. This is where y equals 0. So our x-intercepts are where it crosses that x-axis. And for this, we're just going to estimate. It looks like it's hitting, I guess I kind of covered them up a little bit. We can see the points. Looks like it's crossing right here at negative 1. And it crosses again right here at 3. So to find x-intercepts, we just graph the parabola and then we estimate where it crosses. When we're looking for y-intercepts, we can find them more exactly. The y-intercepts are where x equals 0. Well, it's easy to plug in 0 for each of these values of x. So we say y equals negative 1/3 times 0 squared plus 2/3 times 0 plus 1. And when we simplify that, we get 0 plus 0 plus 1 is 1. So the y-intercept is 1. And we can tell from the graph that looks like that's correct. So we have found the x-intercepts and the y-intercepts. Said that backwards here. This is the x-intercepts, and this is the y-intercept. All right. In section 4.2, we get into translating parabolas. We know that translating is like a slide. It's where we take the shape and we move it around. We're going to start with this as our basic shape, y equals 2x squared. It's got that 2, so it's a little bit narrower than your regular y equals x squared. Now when we graph y equals 2 times x minus 3, what's different? Well, inside what's being squared, we have a minus 3. What did that do to our parabola? How did it move? Well, it moved 1, 2, 3 to the right. So when we have that minus 3 inside, it moves us 3 to the right. What do you think would happen if it had been a plus 3? It's going to move the opposite direction, so it would have moved 3 to the left instead and been over here. Now when we take this equation, y equals 2x squared minus 1, we're subtracting again, but you see it's not part of what's being squared, it's out to the side. And for this one, it appears to have been shifted down 1. And that's from that minus 1. You'll notice all of these parabolas have the same shape because they all have an a of 2. The last parabola I showed you here has 2 different shifts. It has the minus 3 and the minus 1. And you'll see that one moved 3 to the right, 1, 2, 3, and down 1. So it had 2 shifts, 3 right and 1 down. All right, we'll talk about these more in class.